Commodores. This is Ed Dunn coming to you live again from my office. Not so live, but here we are. I'm going to run through our stages, rigging, and safety PowerPoint presentation just so you guys have a little study guide for that, because I know we missed a couple people with COVID and queues and all that jazz. So I'm going to try and run through this real quick to give you guys kind of the benefit of that. Let me just make sure we got everything here. Okay, so stages, rigging, and safety, our first unit in the old Stagecraft compendium. We're going to talk a little bit about origins of theater and why we exist and why we're here. We got to go back, primarily, at least in terms of documentable human history. We kind of look back to the Greeks, Greek theater. Most of it, all of it, really was outdoor theater. So you see there in the background image an example of an outdoor space where performances would take place. You have the arena-style seating that is all kind of focused around a central point there, the amphitheater, which is still, you still see amphitheaters today. Outdoor theater is still a common occurrence around the world. That we utilize. But in terms of Greek theater, obviously we're talking about antiquity, so you have acoustic performances, obviously no audio amplification or any of the technical stuff we have today, but that doesn't necessarily mean that they did not employ the technology of the time. There's a lot of thought that goes into saying that the Greeks had better acoustics than we do today. I don't know if that's true, but they definitely knew what they were doing. And these amphitheaters were designed such that a person standing there projecting their speech could be pretty well heard in the entire vicinity of the seating area. So acoustics were incredibly important. The other aspect that we get from Greek theater is the concept of a raked stage. A raked stage is one that slopes upward as it goes upstage or to the back of the stage. And the idea there was that it allowed kind of a visual reference for distance, and providing that, someone far away would be far upstage, would be back in the back, and then they would physically be higher. So it kind of gave a perspective or a forced perspective look that they like to use. The other aspect of Greek theater that we still employ today involves the backdrop. And you can't see it here, but if I were to, draw in a little thing, you can see there are the ruins of a building here, which would have served as the backdrop or the scene house, and allowed performers to enter and exit through the sides. I want to say in Roman theater that was called the vomitorium, which gets mistranslated as a place after you've done binge eating, you go and vomit, but that's not the actual use of it. It's just the entrance and exit for performers coming in off the side there. But yeah, you would store your scenery and your actors and costumes and stuff could happen in this building here, but then it could also be painted to, show time and place or just have a nice design on it. And then, of course, your stage here. So the different kinds of stages and theaters that we have, keeping in mind that for a long time it was all outdoor. Indoor theater kind of started propagating around the classical era. You started getting buildings that could be constructed to house a lot of people. But there's approximately 5 different forms of theater, and there is some overlap in between that. The theater that we're going to be most familiar with is the proscenium, or proscenium. And the concept there is that you have a proscenium arch that essentially acts as a fourth wall. The action happens here on the stage, and then the audience sits out on the other side of that arch, and that fourth wall is what the actors are playing to. The other idea of staging is the thrust stage, where you have part of the stage that extends out into the audience areas. In this case up here with this purple backdrop, it's a 3/4 thrust. But you can have thrust stages in proscenium stages kind of mixed together. You have a bit of a thrust here. It's not quite as dramatic as the one on the right, but it does exist with the proscenium. And in fact, you could have somewhat of a proscenium in this circumstance over here. Another style of theater can be considered the arena theater, and that's kind of portrayed by this example down here. You have audience sitting all the way around, completely circumferencing the acting areas. This presents a lot of issues with lighting because the audience is now in a 360-degree view of the performers, so you need to be able to light them appropriately from all angles. If you choose to do a dramatic light from one side, you're going to leave half of that performer in the dark on the other, and half the audience isn't going to see that aspect of it, which maybe that's what you're going for, but it is something to consider when the audience is fully encompassing the performance. Another type of theater that's very prevalent today is the black box, and that's this example here down in the middle. And you can see it's literally a box that's black, and it up on the top here, there's usually some sort of grid that you can walk on, and you can hang lights so you can pinpoint different areas throughout the theater. You can also set up and arrange seating however you want. So black box could be set up like a proscenium, or hang drapes and stuff like that to create an audience separation. You could do like a thrust stage or an arena stage as well. And then the last form of theater that you'll encounter is the environmental, and this is just a picture of an outdoor theater experience. Environmental theater seeks to kind of reestablish what we determine is the actual building of the theater. And sometimes that's not a building at all. Things that come to mind with that would be, like theater in random spaces like you see on YouTube, the guys that perform in subways or in places that it's unexpected. So theater in itself doesn't necessarily need a building to exist, but it's really about the performance aspect of it, and our jobs as technicians is how do we influence that performance with sound and light and scenery and rigging to augment it. And environmental theater is all about using the space that you have and augmenting it with whatever equipment you can have. So we're going to kind of shift back to our theater. Ours is a proscenium theater, and you have different parts of this theater. You have the acting area, which is the stage, and everything kind of functions around that. The auditorium is actually the area where the audience sits. And there's usually some sort of scenic background. In our situation, we have a fly system, so we can raise and lower different things from the fly area to change or provide a background. In all forms of public spaces, you do need to have some areas for the audience, refreshment or lobby, restrooms. So those facilities are usually in an area called the front of house. And that's where you take care of most of the business side of the endeavor, getting tickets and things like that. In the back of house, you do have the scene dock here, and in this example, the wardrobe or dressing rooms are actually in the basement. In our building, this is actually a floor plan for our building. The dressing rooms are in the back, and then the scene shop is over on the right side here. Trap room pit. So underneath the stage, there is some Michael Jackson playing "It's Time to Change Classes." So you have storage space under the stage. If we wanted to utilize our trap door, that would be the area that we would use. And then, of course, there's storage. We have storage under the seats, and then in the loft areas above both the dressing rooms and the workshop and the drama room. Okay. So let's talk a little bit about stage direction. We talked about the raked stage. So literally, when you were moving upstage, you were going up, and when you were moving downstage, you'd go down. So we divide front to back in terms of up and down stage or center, and then left and right. You may notice right is on the left in this image and left is on the right, but this is interpreting as what a performer would see. So you point down, you're looking at the audience. On your left is stage left, and on your right is stage right, and you can pretty much divide the stage into different areas by saying downstage right or downstage left or upstage left or just stage left. So that helps us communicate where we're putting things and where we're moving. Yeah. Okay, we're back again. Sorry for the interruption, but we'll cut that out. So, where are we? Let me move back so I don't knock my camera down. So we're talking about stage direction, left, right, up, down. In front of the proscenium line, which is the imaginary line, sometimes it's called the P line or the plaster line. Downstage of that is the apron, which again is a form of thrust stage that exists there over the pit generally. There are, now that we've talked about stage direction and the like, there are 3 forms of rigging systems that we're going to learn about. The first is the oldest, and it is called a hemp or hemp house or hemp rigging system. And it uses, as you can see in the image up here on the top, uses manila rope or hemp rope. It's weighted with sandbags. So what they would actually do is to counterbalance the scenery they were hanging, they would attach sandbags to the lift lines and then add sandbags or take away sandbags to balance it. So you can see that it was definitely tricky. You definitely had to know your knots and rigging and be aware of what you're doing. It's a little bit more dangerous, and it's slightly weaker than what you would find in our system, which is a counterweight rigging system. Instead of sandbags, it uses these metal arbors to kind of contain the weights, usually using iron or steel, occasionally lead, just basically heavy pieces of metal in order to balance the scenery. And you have 2 different types of counterweight rigging systems, single or double purchase. Double purchase allows you to have a much shorter rigging system, so if you had a confined space, you'd typically go with that. Ours is a single purchase, and the downside of a double purchase versus a single is the double, actually, because of the way the ropes are run, it uses twice as much weight for everything. Everything is twice as heavy. And then the last type is the electric winch. We do not have this. However, it is becoming more and more popular, particularly with electrics and curtains that you don't have to move too terribly often. The nice part about the electric winch is it handles all of your load balancing. Sometimes there'll be a counterweight rigged into the system, so you'd have some type of motor attached to a winch that would then run the cables up and down. So there may be a weight in this part of the system there to just balance 50% of the maximum load. Downsides to this is it's expensive and slow. If you need it to go fast, it's even more expensive. But like I said, it's good for things like electrics where you're constantly reweighting them and you don't have to move them that often. Usually you set the electrics, the lighting at the trim you want, and you leave it. So in our system, like I said, we are a single purchase counterweight. There are 29 line sets plus the fire curtain. There is an elevated lock rail, and our grid, the top of our fly system up here, is at 50 feet off of the stage deck. So let's go over parts of the system. There are many, but we're going to start up at the top and kind of work our way around. So this here is an example of one line set, that whole thing right there. So if we start here at the top, the batten is the large bar that hangs and suspends over the stage. And from this, we can attach all the scenery. So if you had like a wall you were flying, you would attach it with lift lines to the batten, the bar, but we call it a batten. Attached to the batten are lift lines that run individually over the top of the fly system and then back down and attach here to the arbor, which we'll get to in a second. The lift lines run through pulleys that are directly over the stage and spread out. We have, I want to say, 6 over our stage. This example only has 3, and these are called loft blocks. The lift lines run through the loft blocks and then eventually reach a large block called the head block, which then routes them down to the arbor. Okay, so the arbor is the metal frame that we use to hold all of the weights and counterbalance the lift line. So whatever you hang here has to be counterbalanced here. And this is just like a big seesaw with the head block as the fulcrum. Also running through that head block is the purchase line. The purchase line is a rope that attaches to the top of the arbor, runs through the head block, through the rope block, down around this bottom block, and then attaches to the bottom of the arbor. So as you pull this down, the other side of it is pulled up. It's a big loop with the arbor in the middle. So that's how we control the batten. So as that arbor comes up, the batten's going to want to come down, and vice versa. To prevent it from moving, we do have a rope lock on the lock rail, which is this bridge here. In our situation, the lock rail is elevated. In most stages, that lock rail is going to be on the deck, where it's easily accessible. Ours is up in the air. But yeah, that lock rail allows you to stop the purchase line from traveling, but the lock rail is not a true lock. It can only hold about 50 pounds before it starts to slip through. So if you had a lot of weight hanging on here and not enough weight hanging here, it would start slipping through the lock rail and could result in a situation called a runaway, which is where the line set's moving far faster than anyone can control. Kind of the opposite of the head block, which is up here, is the tension block down here. And the tension block actually can move up or down, and that allows you to apply tension to the purchase line to keep it nice and tight so it's easier to pull. And then up at the very top of the fly system is a loading bridge. The loading bridge is where we can attach weights, because remember, if the arbor is all the way up at the top, that batten is going to be on the stage deck, which is usually where it is when we need to hang stuff. There are situations where the batten may be at like halfway, and the arbor would also be at halfway, and that's when we would load from like the lock rail. So it just depends on what we're flying. Different types of curtains in the hanging in the theater. We've got the valance, which is this first curtain here. It is what hides like the first electric, and most of the rigging stuff that you see over there is just a masking curtain. The main drape, or grand drape, or main rag, or main traveler, is the first curtain after the valance, and that is what it's sometimes called an act curtain because it comes in at the end of acts, and that just is, it's a main curtain to kind of block everything on the stage. Borders are like valances, except they're just further back. So you have a couple borders there. Depending on how deep your stage is, you may have one or two or four. It just depends how far it goes back. Legs are the curtains that are here on the side. And what they do is, if the audience is sitting here, or they do, it prevents them from seeing into those backstage areas. So it gives actors a place to hide and kind of frames the scenery and everything there. Travelers, essentially traveler is just a name for a curtain that is hung across the entire stage, and usually it's in two sections. And when you pull a rope on the wings, those curtains can open out like that. The main curtain, the mid curtain, and the rear curtain that we have are all travelers, and they function to block off large areas of the stage. We also have a material called scrim, and you can see in that image right there, it's very translucent. It's basically like screen door material, but fabric. And that allows us to do a lot of different kinds of effects. If you hang a scrim in front of like actors, so let's say that scrim was like mid-stage there and you had actors behind it, they could be made to like appear or disappear based on where the lighting's coming. If you shine light on a scrim from the front, it will become kind of opaque and hard to see through. If you light just behind it and no light on the front, then it's like see-through, but it looks like you're looking through screens, so it can kind of look hazy, or I think it sometimes looks like an oil painting, especially if you have the actors kind of striking a pose like in a tableau or something. We also have backdrops in our cyclorama. So anything that's all the way at the back, it can be painted to look like a space, or an area or whatever you're trying to do for the scene. The cyclorama is kind of a misnomer. A cyclorama is actually a curved curtain that kind of indicates infinity. So it just gives you that white space, and it looks like it goes on forever. Our cyclorama is actually more correctly called a sky drop, and it's just, again, it's a white or light blue curtain that kind of gives you the idea of infinity. You can color it to look like a sky, or just like a colored backdrop. And then there's dedicated line sets. We've already talked about electrics, or like specific curtains and things like that. So if a line set is always going to have like the main drape on it, that is a dedicated line set. If a line set has all the electrical wiring for lights and such, that is an electric. It's a dedicated line set. So when you're working the rail, there's a couple things you need to know. The person operating the rail is the flyman or the flywoman or the rigging operator. They're in charge of everything that goes on in that space regarding moving of rigging. So it's important this person knows where things are, where they're going, and is communicating that to everybody in the building. Anytime you're moving a line set, you need to call it. So you need to have clear instructions, as it says there. And there's 3 components to that. What line set you're moving, what direction it's going, and then you wait for the acknowledgement from the stage. So let's say we're moving the main curtain down. So in that case, you would call out main curtain coming in. And we say coming in when we're moving a curtain down because it's coming into the view of the audience. So the opposite of that would be main curtain coming out. So if it's coming in, so you're dropping the main curtain, you'd say main curtain coming in, and then you'd wait for the people on the stage to acknowledge it by saying, thank you, main, clear, okay. Or if there's an issue, they would say hold or stop or not yet. But that acknowledgement is key to making sure that people know what they're doing. Anytime a line set's not in use, this lock handle needs to remain up with the safety ring on, just so that it can't accidentally move on its own or somebody comes and messes with it. That's important. Anything you notice that's not right up here should definitely be reported, even if you're not sure. If it looks like something is weird or it's different than the last time you were up there, definitely let someone know. It may be nothing, it may be something, but everybody needs to be eyes and ears on this. And then lastly, on this slide, the 4 Ks of rigging. This came from a guy named Jay Glarum, who wrote a book on rigging called Stage Rigging Handbook. I had to look over there because I couldn't quite remember the name. But yeah, the Stage Rigging Handbook that goes over a lot more detail than what we're going to talk about in this PowerPoint. But I love his 4Ks of rigging because it really gives you an idea of what you need to do. The first K is know the system. So that's what we're doing now, is we're learning about the system. Second K is keep it in working order, which goes again with reporting things that don't seem right. Know how to use it. We're going to train on it. We're going to practice it and get comfortable with it. And then keep your concentration. That last one's important because if you're like me, you're easily distracted, and that's okay. That happens. But when you're moving line sets, your focus needs to be 100% on where that scenery is going, where that bar's going. Is there anything in the way? Is there going to be anything in the way? And if you can't keep your concentration, you need to lock it and stop and figure out whatever's distracting you before you continue. That's super important. One other note in terms of safety is keep your weight down. The idea there is that you want the heaviest part of a line set, if you have to take it out of balance for whatever reason, and we do. When we're loading, we're adding weight to the line set. That's naturally going to make it go out of balance. So it's important to keep the heavy part of the line set at the bottom of the system. In cases where you remove weight from a batten before removing weight from the arbor, if your arbor is elevated and your batten's not, now this is the lightest part and the system is going to want to run away. I have an example of that in the other rigging video that you can watch and see. Here's some other examples of some scary rigging and some weird things. In this case, these guys tied on some weights to the bottom of an arbor to increase its capacity, which is not a good idea. Here's a screw kind of acting as a shackle, I guess, to hold that all together. This line set was labeled 200 pounds out of weight. There's no reason why you would want to leave something like that and then have it only prevented from being unlocked by just the lock and a piece of spike tape. That's pretty dangerous because anybody could come up, not see that, and pull that and open it, and then you have a runaway. Here's another example of stacking weight improperly. This is what happens when an arbor crashes, and you can see here a couple things that are important. Notice that the angle of the bottom of the arbor went down. As these things hit this stopper rail here, or this crash bar, the weight is going to want to keep going. So in this case, it bends forward. It distorts the arbor rods, and if this keeper plate wasn't in place, this could bend all the way out, and then all of a sudden all these weights are going to be ejected out towards the stage. So it's very important that there's a little screw clips on those keeper plates. You want to make sure that that's tight and secure because that will prevent this arbor rod from splitting open and the weights from being ejected. And then here's another one. They hung, looks like with safeties underneath this. Again, arbors have a specific capacity that you want to use in order. Okay, moving along. So troubleshooting, if a line set won't move, you shouldn't just try and yank on it, because there could be something on the stage that hung it up. There could be a curtain that's draped over it. Anytime something won't move, lock it, try and figure out what's going on, visual inspection. And if you can't figure it out yourself, get me, get your TD, whatever. A line set moves too easily. Maybe you ran it earlier and all of a sudden now it's really moving. That's a situation where you want to figure out what's going on. Again, lock it, find out why it's moving too easily. Maybe somebody took weight off the batten on the stage, didn't realize the arbor still had weight on it, whatever. If it sounds different, if it feels different, if it smells different, all of these things, trust your senses, because when something's different, it usually means something has changed. And if something's changed, it could have changed poorly, and then putting an undue stress on the system. Like if it's groaning or creaking or grinding and you feel the vibrations in the rope, that means something's rubbing, and maybe there's an issue. This one's probably the most common, is a missed or missing spike. So if you lose track of a spike mark, it's your job as operator of the rail to make sure that your spikes are in the right place and you know where each line set should start and stop. So that's easily fixed. Another part of rigging is tying knots, and I'm not going to go into that too much with this video, but there are, I would say, 4 basic knots that you need to be aware of in terms of rigging: the bowline, the clove hitch, 2 half hitches, and then the belaying knot. The belaying knot we use up on the pin rail to tie off, and in our particular instance, we tie off electric drops that are just extra drops our building happens to be equipped with. But belaying in any theater, you're going to have a bunch of different reasons why you would need to belay. So it's important to learn that knot, especially for us. But the bowline is a good way to add a loop that will not cinch up. So as tension is pulled on this rope, this loop will remain the same. So that's a very useful knot. The bowline also only reduces the effectiveness of the rope by about 60%, if I'm remembering correctly. And I want to say the 2 half hitches actually, which serves a similar purpose, the 2 half hitches will choke against a bar. So when this has tension on it like that, this circular part will in fact get tighter. But if I'm not mistaken, the 2 half hitches derates it a little bit more than 60%, or 40%, down to 60%. And then the clove hitch is another great knot for tying onto a bar. It's also a really easy knot to tie onto a bar with. And both of these knots, the clove hitch and the 2 half hitches, you can take the standing end and tie a half hitch around the line, the load part of the line, to kind of lock it into place. So these 3 knots in particular, good knots to know for theater, but just really in real life. Bowline can save your life. It's a good knot to know. All right, rigging hardware. There's a bunch of different hardware that you have to know about, and unfortunately in this slideshow I don't think I have pictures of it, but there is a list here that we'll get into. But this next set of slides does kind of talk about the different things. Chain is pretty obvious. Wire rope is, there's an example of it right here, is essentially rope that's woven together, but instead of made out of natural fiber, it's made out of steel, or galvanized steel. It's a lot stronger than rope, obviously, because it just has a greater tensile strength. We terminate wire rope in a variety of ways, but one of those is using cable clips or the Nico press tool. Thimbles, which I think I have pictures of these. Yeah, so let's go on. We'll attack these as we go through this next part. So chain and wire rope, you can see here. Chain, we use rated chain, so it'll have some sort of stamp on it that indicates what it is. We typically use grade 30 proof coil or better. Grade 30 proof coil is technically not rated for overhead lifting, but it is a very common chain in theatrical applications, and I've been told by many different manufacturers that it is acceptable to hang scenery and such with grade 30 chain. What you definitely don't want to use is the welded or unrated chain. So if it doesn't have that stamp on it, or you see something like this where it's clearly that it was welded together, This chain is not rated for use of hanging anything, and it may have an unknown breaking factor, which makes it hard to know how much you can hang off of it. We almost always use 7x19 galvanized aircraft cable, which is wire rope, and if you were to slice it in half, like that, you would see a cross-section that looks like this. And you can see there are 7 cores, right? 1, 2, 3, 4, 5, 6 around a center one, which is 7. And inside each of those 7 cores is 19 different strands. So that's where you get 7x19. Terminating wire rope and chain, we use a couple different things. I mentioned the cable clips and Nico press. This is an example of a Nico press. Inside the little loop that it's created is a thimble, which is just a thin piece of metal that kind of forms the wire rope into a nice shape, and it prevents it from being kinked or bent. So you can imagine if you just took a loop of wire rope and then put it around a point, it would get very tight against that point, and that's going to wear it out and potentially break it. So thimbles are important to use in any loops, whether you're using the Nico or, as this example down here, that's what a cable clip looks like, and it's 2 parts. It's a U-bolt and a saddle, and then you bolt the U-bolt into that saddle, and it compresses the 2 pieces of wire rope together. An important thing with the cable clips in terms of installing them is you never want to saddle a dead horse. What that means is you can see the lift part of the line. Let me start over with the ink here. So this is the load right here. This is what's pulling against wherever we're attaching this to. So that's going to come in through here, loop around, and then the standing end comes all the way back up to here. Okay? You never want to put the saddle part on this side of the line. That's saddling a dead horse. The dead part of the line's not taking any of the weight. The U-bolt is what compresses that standing line into the saddle. So it's important you never saddle a dead horse. Just keep that in the back of your mind. Screw pin shackles are these guys here. I'll clean up some of this ink. It has a pin that screws into a bell shackle, right? And the nice part about the shackle is the bell shape of it allows you to have a couple different points hung from this part of it. But on the pin part, you only want to have one. So in the example up here, they've got a lift line coming in. It's terminated with a Nico and then a thimble, and then they installed a piece of chain. So one link of chain is in that cable thimble, and it's permanently installed now. The chain comes down, wraps around the bar once. This is important. You need 1.5 wraps. Comes back up. It connects to the screw pin of the shackle, and then the bell end of the shackle connects into the thimble of the lift line. Now, the other way you could do this is, let's say you didn't have the chain in that thimble. You could hang your shackle, pin up, and let's see, we'll try and draw a shackle here. Bell down. Look at that. It's pretty good. And then have your 2 chains kind of intersecting in the bell, and then your cable thimble with your lift line intersecting with the pin. It would not be appropriate to do this opposite. You would not want to have 2 chains going in there. The other thing to keep in mind is you don't want to side load these things, so sometimes they get turned around. So instead of having something in the thimble or on the pin side, you may have it pulling 2 parts of the bell apart. And what that will do is it will weaken it, and it eventually will fail. It's not designed to be loaded that way. Other types of rigging hardware, we have scenery hangers, and these are kind of coming out of style. It used to be, for a long time, these were super cool and everybody loved them. They have like a bottom hanger, which is this little guy, and it's a J shape, and the scenery just kind of slots in there, and then you can bolt through it, which is great, or screw through it. Anytime we're hanging scenery, I want to have at least 1 bolt in every piece of hardware, just because bolts do not shear as easily as screws. And when you're loading and lifting stuff, you're applying shock loads to things. The screws can shear off, and that's bad. Bad news bears. So yeah, these scenery hangers are really just a piece of steel that's like folded. You can see up in the top here, this is just folded over this D-ring. There's not a whole lot that is preventing this thing from coming undone. Sometimes there's like a little tack, a weld on there, and that may be great, but they're not really rated for anything. A couple companies are coming out with rated scenic hangers, and again, same kind of concept, but instead of the D-ring and the folded piece, you have a single piece that's bent and rated and tested, and you can see it comes with documentation of like, okay, if you're hanging it this way, you get 400 pounds, if you're hanging it this way, you get 600 pounds, or in this case, it says do not use, you're not going to hang it down that way. Actually, it's backwards. You would hang it this way, you can't hang it that way because it could pull up and bend. Or vice versa, you can't pull from that way, and it tells you get 600 pounds hanging it like it's directed to. So that's cool. Those things are neat, and I'm looking forward to picking a couple of them up and trying them out and phasing out our old busted hardware. Another way to attach to the batten is something called a batten clamp. So you can use chain like we did in the last slide, but they also make these clamps that kind of sandwich the bar, and then you bolt them together, and then it has a spot for the shackle to interact with it, which is super cool. Again, a very safe way to hang things. Another gizmo that we sometimes use is the turnbuckle, and that's this guy right here. And you can see it has kind of a shackle end here and a shackle end here. So you attach this in between your lift line and your scenic piece, because this middle part is a screw, and when you rotate it one way it will get longer, so you can increase the length on the lift line, or vice versa, if you tighten it down it gets shorter. And the benefit there is, let's say you're hanging 2 lift lines on a piece of scenery and this side is higher than the other. Well, instead of having to re-rig all this stuff, you just turn the shackle until it's nice and square. So the turnbuckle, I'm sorry, you use, I think I said shackle. You turn the turnbuckle until it's square. So the turnbuckle prevents you from having to deal with unbalanced things and uneven things. Eye bolts are these guys right here. We sometimes see screw eye bolts like this, where the idea is that it would lag into a piece of wood. We don't like those just because they can pull out. The wood can be soft and it can work its way out over time. So anytime we're using eye bolts on scenery, we're going to definitely use the threaded machine threads and then a nut and a washer on the end of it to lock it in there, make sure it doesn't come out. Stuff to consider. Anytime you're rigging things, you definitely want to bolt it together. Screws will pull out, they weaken over time. The wood is a natural material, so as it moves up and down, that screw will eventually wobble in there and it will come loose. The bolt is straight through, you have a nut, you can put a lock washer on it, and it's nice and tight. It's not going anywhere. Other things to consider when you're hanging things is the load path. So in this example here, we have 2 chains coming from there, and if you notice there's a link just kind of sitting here. That is an acceptable way to hang with chain if you have the room in the chain links to do it. You can see that effectively they made 2 different chain links here. The load is being carried on the tensioned parts, and then this guy's just sitting in the middle. You never would want to put a shackle through one link of chain and have it go like that, because then that one link is going to be stressed in ways we can't predict. Bridling is essentially taking 2 lift lines and connecting them together to lift a single load. Things to consider with that are the angle of the bridle, and in this case they have a 10,000 pound example, and because we have 30 degrees of the bridle here, the 30 degrees we're measuring on this little triangle angle we've got here, that actually increases the weight, the tension on those lift lines, because not only are you pulling them up, you're also adding a side load force. So that effectively doubles the amount of weight being carried by that part of the lift line. So even though this vertical lift line is still only experiencing 10,000 pounds, these individual lift lines are both experiencing 10,000 pounds on their own. And the other thing is, the steeper that angle gets, so let's say that's 15 degrees, it could be 20,000 pounds of force on there. The deeper that angle gets, the more weight is being carried by that. Lastly, on this slide, things to consider: mousing hardware. So on the screw pin shackles, there's little holes, and then you can just take a piece of wire rope or wire, something like that, and just kind of work it over through there. Another way to do that is zip ties, and that prevents that screw from working itself out. Basically, it's just another way to safety it. Fire safety in the theater, things to consider. I need to get a Coke as well. Stay hydrated. Anyways, Fire safety in the theater, there's a couple things to consider. Flame proofing does not mean that it is fireproof. We flame proof some things, scenery, on occasion, fabrics. All of our curtains are what is called inherently fire retardant, which means that they won't immediately burst into flames when exposed to a flame. They may smolder or melt or whatever, but they're not just going to burst into flames. But they will eventually burn over time. So it just kind of buys you time to deal with whatever's on fire and prevent it from burning the place down. Other safety devices we have in the theater, this is an example of a fire curtain. A fire curtain comes down and it provides an air barrier between the audience and the stage. So assuming the fire breaks out here on the stage, there's smoke and all kinds of nasty stuff going on, the fire curtain comes down, it separates the audience, it buys them time to get out. That's what's important, is time in a fire. You want to have time to get out of the building. Sprinklers, kind of the same thing. It will slow a fire down. It could knock a fire down completely. Most sprinklers have some sort of glass capsule in them or a metal device that will melt at a certain temperature. In the case of the glass, it's going to blow up and it'll allow this little stopper to come down, and then the water's going to flow and spray down the fire. So once it gets to a certain temperature, or a freshman hits it with a 2x4, it will start spraying water. Other devices you have, fire extinguishers, hoses. There used to be hoses in theaters, and then they took them out because the whole rationale has shifted from we need to prevent the fire from destroying the building to we need to get everybody outside, and who cares about the building because we have insurance. Insurance cannot replace lives, but it can replace stuff. So the idea with fire safety in the theater is really just about buying time for the audience to get the heck out. Individual safety. We all learned a lot about personal protective equipment, or PPE, in the past pandemic, but that also applies to doing our job in the theater. A big one that we often forget about is footwear. There's a lot of ways that you can injure your feet, dropping things on them, stepping on things. So it's important to wear good shoes in the theater. Eye protection and ear protection, using tools that tend to be noisy. You want to protect your hearing, because that's something that you don't immediately notice you've damaged. Over time, you eventually will lose hearing if you're exposing yourself to running tools all the time. Eye protection is a little bit more obvious. Anytime you're dealing with the tool that's spinning, or you're working on something where there's a risk of something coming and hitting you in the eye, you need to wear goggles, safety goggles. We do supply those here. I do have a bag of foam earplugs, but you may want to explore getting your own. They're not too expensive. I just got a pair. I think I have them in my pocket. They're called Etymotics, and I really like them because, unlike the foam ear pieces, these are dirty, sorry, kind of gross. These things reduce the volume by about 20 dB, but they do it flat. So like when I put them in, I can still hear stuff. It's just like the volume's turned down. So it doesn't just immediately crush the high frequencies and let low frequencies through like sometimes happens with the foam ones. It's pretty even about how it knocks stuff down. Respirators, we all know about those. Those face masks that we've been wearing for the better part of 2 years now, gosh, are considered some form of respirators. These ones, like you have for COVID, are essentially just dust masks. They're surgical masks, whatever. But even this is good for just keeping like wood dust out of your nose. And over time, that can cause injuries and irritate your inside of your respiratory system, which is not good. I knew a guy that was allergic to the wood glue that they put in plywood. So anytime we were cutting sheets of plywood on the saws, he would have to get out of there, put on a respirator. Gloves, where did I put them? I just got these gloves too. These are really nice. These are called gig gloves, and they're very fancy. But they have a lot of protective features. They have some Velcro and protection on the pads of your hands. The fingers have little spots so you can put your finger out. There's knuckle protection. There's for the fingers, individual stuff like that. I really like these. They're not too expensive. I think like $25-$30, which is pretty good for a pair of gloves. But yeah, pushing stuff around, moving stuff, splinters, all that, gloves protect against that. It's important. Helmets are something that are becoming more popular in theaters these days, particularly when you're dealing with rigging. anytime you're up and you're crouched down and you're moving around, it's good to have like a bump cap on so that if you bang into a piece of metal just moving around, it's going to prevent you from getting injured, cutting your head open or whatever. But if anytime you find yourself working with people working above you, it's a good idea to wear a helmet because they could drop something and then, even something small and innocuous is going to cause damage if it falls from high enough. Chemical precautions, we don't necessarily have too many of those. Occasionally we use spray paint. That seems to be the biggest thing that we encounter in terms of chemical, and that's just about ventilation, making sure that you're not doing that in a confined space where you're going to be affected by the vapors coming out of it. Hazards while you're working with tools and moving stuff, long hair is a thing, make sure your hair's up. Fortunately, there's not too many hazards sitting here doing a video that I need to put my hair up. But loose clothing and jewelry, all of this stuff, when you're working around tools that spin fast, present a safety hazard because that could get caught in the spinning tool and then all of a sudden you're being drawn towards the tool. So be aware of what you're wearing and what your hair's doing when you're dealing with that kind of stuff. Working at heights safely. Here we have an example, a picture of a dude that's leaning out. This is a balcony railing. You can see there's audience seating behind him. So this is a front of house lighting position on a balcony, and it's accessible from that, but he's leaning out, and a good percentage of his body weight is out over this rail. Like, if this is the balance point, most of his torso is out over that. So there's a risk that he could fall. And to mitigate that risk, he's wearing a harness and he's clipped in with a D-ring, and that line is pretty tight. So that tells me that that is fall prevention or fall restraint as opposed to fall protection, because it is preventing him from leaning out to the point where he would fall. I'm also assuming that if he did fall, that would hold him. It would prevent him from falling, presumably to his death. He's also wearing a helmet, which in this circumstance, I mean, that may be a little bit much unless there's another rail above him where people are also working, but you can't be too safe. So, when you're leaning out over a railing, which it says don't do that, you should clip in, and that's what this process is. He's clipped into something that will prevent him from falling. We never throw anything down from a catwalk. That's just good practice to avoid creating situations where things are falling. Somebody may not be aware of it. You may overthrow it. It may hit somebody, but we just never throw anything. Either walk it down, or there's a bucket on Bridge 2 that we use to lower things down. When you're up and using tools, I can't see in this picture if he's got a tool in his hand. He may just be adjusting something. But you want to use a lanyard. A lanyard would attach to the tool and then attach it to your body, or sometimes you can attach it to like the rail that you're working on, and that prevents you, if you drop it, it's not going to go all the way down. It's going to stop. You never want to leave things where they could fall. In this case, he may have his phone out, set his phone on the rail here, and then when he gets up to leave, he bumps it and it falls and hits somebody. So never, when you're upstairs working at heights, these are really important things to keep in mind, because you can take it for granted. We get used to working up there and we don't always pay attention to what's underneath us. So you always want to be aware of what's down there and that anything you're interacting with can't fall inadvertently. When you're using a ladder, there's some other considerations. You don't want to overreach on a ladder. So if you're using like a typical A-frame ladder and you're up here and you reach to the left or to the right, that ladder can fall. I've been on a ladder situation where it can, start wobbling or whatever, and that ladder tips over and falls, and that's not good. It's not fun to fall off a ladder, and it can cause you to have permanent injuries. So you always want to make sure the ladder's set up properly. If it's an A-frame, like most of ours are, you want to make sure all 4 legs are flat and even on the ground. It's always a good idea to have a helper hold the ladder to keep it steady while you're moving around on it, because that can prevent you from losing your balance and falling. And you never want to cross that line. All ladders will have a marker on it that says do not stand at or above this height. And that's it. Yeah, it's usually the last 2 steps you'd never want to stand on, because there's nothing for you to hold on to up here, and that's where you could fall off and splat. The last slide talks about our rigging in real life assignment, and the idea there is that you were going to go out into the real world and take a picture of stuff that's hung over your head, or maybe in the case here on the left, these lights I saw at our local zoo, and they were held in with drywall screws, which is great. Not exactly the best way to hang something like that. But whoever did it was very safety conscious because they also used a drywall screw to attach the safety to the rail there. So, you know, in reality, is that ever going to fall? Probably not. But is there a better way to do it? Yeah, I would have preferred, if you're really going to have to screw into the wood like that, you'll definitely want to get some type of like galvanized fastener or lag that would be strong enough to hold most of that load. Hello.
Working on a dungeon, and we were wondering if you had any, like, loose material for us to, like, stuff cursors with.
I mean, any of that stuff we got from Goodies.
I guess so.
Yeah. That's all got to go back there anyways.
Alright, thank you.
But yeah, help yourself. Where was I? Okay, so yeah, if you did have to screw into it for that, there's better ways to do it. They used, I could see, it's hard to see in this picture, but they definitely used drywall screws, which is no bueno. They're going to fail over time because they're just not rated for outdoor use, so they get rusty and eventually fall apart. The example here on the right was our old chiller plant being hoisted out, and you can see they're using a really big crane. Up at the top, these are all span sets or slings that are attached. They have spreader bars, and then they attached with shackles and had even more bridles down here. It was really cool to watch, and it was rigging. It was all hardware that we use in the theater, but just really big because it's a big old chiller about the size of your car. But yeah, the rigging in real life assignment, that was essentially just designed to get you to go out and look up and see what's above your head. It doesn't necessarily have to have a theatrical application, but if you look up when you go out and about your daily life, you're going to see stuff that's hung up there, and sometimes it's hung well and it makes sense and they're using appropriate hardware, and other times it's chaos, and you can learn a lot from both. So check it out next time you're around, and that does complete our thing. So thank you for watching, and I hope this helps you on learning about rigging.